In February 1942, the German battleship Gneisenau accomplished the impossible. During the famous Channel Dash, she raced through the English Channel in a passage that began under cover of darkness and carried her through the Dover Strait in daylight. British forces failed to stop her, though she struck a mine and emerged damaged. It was a staggering tactical victory for the Kriegsmarine. Gneisenau had survived the most dangerous waters on Earth, but she would not survive the safety of home. 2 weeks later, while she rested in a heavily defended floating dry dock at Kiel, RAF bombers attacked the port under cover of darkness. One bomb penetrated the armored deck near the forward turret and exploded below, starting a fire that ignited exposed propellant charges in the forward ammunition spaces. The horrific blast killed 112 men, deformed her forward turret, and took the swift warship entirely out of the fight. Yet, the bomb did not sink the Gneisenau. Instead, it handed the German Naval High Command an excuse to do something entirely unprecedented. They decided not merely to patch the hole, but to tear the ship apart and rebuild her into a vessel capable of destroying anything on the ocean. It was a desperate engineering gamble that would require them to cut away the damaged bow and rebuild the forward end of the battleship. And it raises a bizarre historical question. Why did a bomb that only damaged a ship spark a massive reconstruction project that ultimately ensured Gneisenau would never sail again? To understand why the German Naval High Command decided to tear a battleship apart, you have to look back to the world before the war, when the ship was little more than an ambitious blueprint. When Gneisenau was laid down at the Deutsche Werke Kiel shipyard in 1935, she was intended to be a masterpiece of national resurgence. For Grand Admiral Erich Raeder, the driving force behind the Kriegsmarine, she was a fast, modern capital ship that would announce Germany's return to the oceans. But beneath the sweeping lines of her hull, Raeder knew his new warship carried a severe tactical compromise. The Scharnhorst class, comprising Gneisenau and her sister ship, emerged from a complicated mix of treaty politics, rivalry with new French capital ships, and Germany's need for fast, heavily armored warships. Commerce raiding was one of their principal missions. They could hunt convoys, outrun slower battleships, and overpower most cruisers. But if cornered by a true, heavily armored battleship, a warship needed true, battleship-caliber weapons to survive. Gneisenau did not have them. Her main battery was composed of 9 28-centimeter guns, roughly 11 inches in diameter. In the brutal calculus of naval artillery, striking power is dictated by the physics of mass and kinetic energy. An 11-inch shell weighed approximately 330 kilograms. It was lethal against cruisers and could penetrate substantial armor under favorable conditions. But against a modern battleship, it offered less penetration, explosive effect, and margin for error than the far heavier shells fired by 15-inch guns. Raeder had never wanted it this way. His original vision for the ships demanded 38-centimeter guns, massive 15-inch weapons that fired an 800-kilogram shell, delivering more than double the destructive weight. A 15-inch shell could crack the armor belt of almost any warship on Earth. But in the mid-1930s, Raeder faced a hard technical and political choice. The 38-centimeter weapon and its twin mounting were not ready for rapid installation, and redesigning the ships around them would have delayed construction substantially. At the same time, German naval policy was still being shaped by treaty diplomacy and by Hitler's desire to avoid provoking Britain too early. The trade-off was stark. Accept the available 28-centimeter armament and get the ships into service, or wait for the heavier guns and absorb a major delay. Raeder chose availability over maximum firepower. The designers nevertheless preserved the possibility of a later 38-centimeter conversion, although the change would still demand major alterations to the barbettes, ammunition handling systems, electrical equipment, and internal structure. The option was built into the design as a future possibility, not as a simple drop-in replacement. Yet, once World War II erupted, Gneisenau proved far too valuable as a surface raider to pull from the front line. The ship was trapped by her own utility, forced to fight a war with weapons her commander knew were inadequate. That changed in February 1942, when the British bomb detonated inside Gneisenau's forward magazine. It devastated the forward turret and reopened the armament question. The ship was broken, but her commander saw an opportunity, a chance to fix a compromise made years before the war began. The morning sun of February 27, 1942, revealed a gruesome reality inside the floating dry dock at Kiel. The forward section of Gneisenau was a scorched, twisted cavern of steel. The British bomb had penetrated the armored deck close to the forward 28-centimeter turret, known as Turret Anton, and exploded in the spaces below. The resulting blast ignited a massive stockpile of volatile propellant charges waiting in the hoists. Warships are designed to compartmentalize disaster, but a magazine fire is a capital ship's most terminal threat. Emergency flooding of the forward ammunition spaces helped contain the fire and may have prevented a far greater explosion. The surviving crew acted quickly to flood the threatened compartments, although the exact sequence and the full scale of the disaster they averted cannot be known with certainty. Flooding helped save the hull, but blast, fire, and extreme heat left the turret's internal machinery wrecked beyond practical repair. Turret Anton was effectively dead, its mechanical guts fused into a useless mass of slag. For a standard naval command, this level of destruction would be a strategic disaster. Assessing the ruined battleship, Raeder concluded that repairing the shattered barbette and replacing the complex 11-inch turret would require extensive shipyard time and thousands of skilled man-hours. If Gneisenau was guaranteed to be sidelined for well over a year, regardless of what they did, Raeder argued it made no strategic sense to spend that precious time merely restoring a flawed compromise. The reconstruction proposal went forward to Hitler for approval. The plan called for all three 28-centimeter triple turrets to be removed and replaced by three 38-centimeter twin turrets, using the same main gun caliber carried by Bismarck. Hitler approved the conversion, committing Germany to a long and resource-intensive rebuild. The trade-off was immense. Germany would willingly forfeit its fastest raider today, trading immediate naval presence for the promise of a far more lethal battleship tomorrow. However, Kiel was far too exposed to British air attack to risk such a prolonged and vulnerable reconstruction. On April 4, 1942, accompanied by fighter cover and escort vessels, the crippled Gneisenau steamed east under her own power to Gotenhofen in occupied Poland. The port was farther from British bases and less vulnerable to routine raids than Kiel, though it was not beyond the reach of long-range RAF operations. There, her engines were shut down, her crew was reassigned, and her damaged hull was formally handed over to the shipyard. The political order was given, but turning a political order into steel now fell to the engineers, who had to solve a devastating mathematical problem. When Gneisenau arrived in Gotenhofen, she was camouflaged and covered with netting to reduce the risk of aerial detection. The Battle of the Atlantic raged on without her, while engineers in the Kriegsmarine's Kriegsschiffbau, the naval construction organization, began turning the political mandate into a workable design. Now, the naval architects had to make the approved conversion obey the laws of physics. To a politician or an enthusiastic public, upgrading a battleship sounds incredibly simple. Remove the damaged weapons, drop the larger guns onto the deck, and send the ship back out to sea. But the K-Amt engineers knew the grim reality. A warship is not a blank canvas. It is a meticulously tuned mathematical formula balancing buoyancy, structural tension, and mass. The proposed 38-centimeter twin turrets were colossal pieces of machinery. While Raeder had ordered the ship's circular steel barbettes to be built wide enough to eventually accept them, Accommodating the sheer mass of the working weapon systems was an entirely different challenge. Each fully loaded 15-inch turret weighed over 1,000 tons. The rotating machinery stretched multiple decks deep into the hull, requiring massive hydraulic systems, widened ammunition elevators, and entirely new loading cages. To make the mathematics work, the K-Amt finalized the physical trade-off. They would remove Gneisenau's 3 triple turrets, completely eliminating her original 9-barrel broadside. In their place, they would install 3 twin turrets, reducing the ship to 6 barrels in total. By sacrificing the volume of fire and the number of shells launched in a single salvo, the designers gained a staggering leap in total destructive mass per hit. But turning this blueprint into reality meant preparing the steel Leviathan for the most invasive surgery in naval history. Throughout the summer of 1942, Gotenhofen shipyard workers swarmed the camouflaged vessel with cutting torches and heavy cranes. They began the brutal procedure of gutting the patient. They ripped away the charred remains of the forward turret Anton and carefully extracted the undamaged superfiring turret Bruno and the aft turret Caesar. Deep inside the hull, the ship's magazines had to be entirely reconstructed. It was no longer a matter of storing the older, lighter ammunition. The new magazines had to safely secure and rapidly hoist massive 800-kilogram armor-piercing rounds. The magazines, shell rooms, hoists, and supporting structure would all have to be rebuilt and reinforced to carry and move the much heavier ammunition safely. Yet, as the engineers refined the calculations, the conversion produced a second problem: the ship's balance and behavior at sea. Solving it would require a drastic alteration to the hull. By the autumn of 1942, the strategic reality of the Second World War was shifting rapidly. The German war machine was bleeding heavily on the Eastern Front, and the Battle of the Atlantic was turning into an unrelenting war of attrition. Steel, labor, and time were suddenly the most precious currencies in the Reich. Yet inside the heavily guarded perimeter of the Gotenhofen Naval Yard, an entire army of skilled shipwrights, welders, and engineers was tied to a single, motionless hull. Every day Gneisenau remained under scaffolding was a day she was not hunting enemy convoys. Every ton of armor plate delivered to her dockside was a ton of high-grade steel diverted from the construction of new U-boats. The ticking clock of the war was growing deafening, but the brutal laws of naval architecture could not be rushed. The K-Amt structural calculations had revealed a physical wall. A warship's speed and seakeeping are strictly dictated by how efficiently its hull parts the water. If the new, massive 15-inch turrets were dropped onto the existing forward barbettes, the intense concentration of weight would push Gneisenau's bow deep into the ocean. Instead of slicing gracefully through the surface, the ship would plow heavily into the waves. The resulting trim could increase hydrodynamic drag, reduce her speed, and worsen a wet bow problem the class already suffered. In heavy seas, more water over the forward decks could interfere with optical range finding and restrict the operation of the forward guns. To keep the battleship from sinking by the head, the engineers had to dramatically increase the vessel's forward buoyancy. They could not simply hollow out the existing forward compartments to save weight. They had to fundamentally alter the shape of the warship to displace more water. The K-Amt issued a drastic, final requirement. To balance the new armament, Gneisenau's bow had to be extended by exactly 10 meters, or roughly 33 feet. Executing this blueprint required one of the most severe industrial operations ever attempted on an active German warship. Gneisenau was carefully maneuvered into a massive dry dock. The colossal steel gates were sealed shut and the ocean was pumped out, leaving the 31,000-ton Leviathan resting entirely on rows of wooden keel blocks. Then, the Gotenhofen shipyard workers went to work with heavy oxyacetylene cutting torches. They began the agonizing process of physically amputating the front of a battleship. Cutting through welded hull plating, frames, decks, and watertight bulkheads, the workers severed the damaged prow from the rest of the hull as sparks showered into the concrete basin. the massive wedge of steel was detached and hauled away, leaving the great warship entirely decapitated. This was the true, crippling cost of the fatal upgrade. Lengthening a capital ship is not a simple matter of welding a hollow steel box onto the front. The new 10-meter extension had to match the hydrodynamic lines of the existing hull, while its longitudinal framing had to join seamlessly with the original structure. Any weakness in the graft could threaten the hull under the torsion and flexing of the North Atlantic. By the winter of 1942, the damaged bow had been cut away, and the shipyard was preparing Gneisenau for a longer replacement. The work had advanced, but the exact state of the new bow when the project was halted remains uncertain. Gneisenau sat in dry dock, cut open and helpless, waiting for a new steel nose. But hundreds of miles away, an entirely different battle was about to seal her fate. As 1943 began, work on Gneisenau continued at Gotenhofen, but the political foundation supporting the project was about to collapse. Its end would come not from an Allied bombing raid, but from Adolf Hitler's East Prussian headquarters. On the final day of December 1942, German naval forces intercepted a British supply convoy in the freezing waters of the Arctic. The resulting clash became known as the Battle of the Barents Sea. Inside his command bunker, Hitler eagerly awaited the after-action reports. The Kriegsmarine had committed a powerful surface squadron, including 2 heavy cruisers, against convoy JW-51B. Its close escort was built around destroyers and smaller vessels, but a supporting force of the light cruisers HMS Sheffield and HMS Jamaica was nearby. Hitler, desperate for positive news to offset the unfolding disaster at Stalingrad, anticipated a total, glorious victory. Instead, the fragmented dispatches that finally reached the High Command painted a picture of humiliating defeat. Operating under strict, pre-existing orders from the Naval High Command to avoid risking damage to major surface units, the German cruiser captains had fought hesitantly. The British destroyers fought back aggressively and bought the convoy precious time. Then Sheffield and Jamaica arrived, damaged Admiral Hipper, and helped sink the German destroyer Friedrich Eckholt. Faced with unexpected cruiser opposition, the German force broke off the attack. When Hitler learned that his massive, heavily armored warships had been chased away by a handful of light escorts, something broke. His initial enthusiasm for the surface fleet, the very enthusiasm that had greenlit the Gneisenau rebuild, vanished in a sudden, catastrophic psychological reversal. He flew into an uncontrollable rage, viewing the retreat not as a tactical decision, but as institutional cowardice. To Hitler, the massive capital ships were nothing but floating steel museums, terrified of scratching their own paint, while German soldiers were bleeding by the hundreds of thousands in the snows of Russia. Grand Admiral Erich Raeder, the man who had championed the Gneisenau reconstruction, was summoned to Hitler's headquarters to face the fallout. On January 6, 1943, Hitler subjected his naval chief to a furious denunciation of the German surface fleet. He demanded that the major ships be decommissioned and their crews and heavy guns reassigned, although the order would later be modified rather than carried out in full. It was a political death sentence for projects such as Gneisenau's reconstruction, even if parts of the surviving surface fleet would remain in service. The decision also stripped Raeder of the authority needed to defend the reconstruction. Raeder was stunned, unable to reconcile himself to the dismantling of the surface fleet, and stripped of the authority to defend projects such as Gneisenau's reconstruction. Raeder tendered his formal resignation. The architect of the rebuild was gone. His successor would judge the project by a very different set of priorities. On January 30, 1943, Grand Admiral Karl Donitz officially assumed command of the Kriegsmarine. He inherited a navy shaken by Hitler's rage and brought with him an overwhelming commitment to the U-boat war. Donitz was not blind to the value of surface ships. He would argue for retaining some of them as a fleet in being. But Gneisenau's incomplete reconstruction offered no immediate return. To him, the project consumed scarce labor, steel, and dockyard capacity, while promising a ship that could not fight for many months. At that moment, Gneisenau remained incomplete and incapable of returning to combat. Continuing the reconstruction promised no operational return for at least another year, while cancellation meant accepting that the money, engineering effort, and loss of the original bow had been wasted. Donitz accepted the sunk cost and released the dockyard capacity for immediate use elsewhere. In early 1943, in the aftermath of Hitler's order and the Navy's reassessment of its surface fleet, work on Gneisenau was halted. The hull was made sufficiently watertight to clear the needed dockyard space, then towed to a harbor berth and laid up with the reconstruction unfinished. Almost overnight, the proud capital ship was subjected to the grim naval reality of cannibalization. When a military economy reaches a point of total war desperation, a halted warship does not merely sit in reserve, it becomes an active quarry. The Kriegsmarine urgently needed raw materials to keep its surviving fleets operational. Slowly, workers returned to the camouflaged hulk, not to rebuild it, but to remove equipment that could still be used elsewhere. The main armament had already been taken ashore, and other valuable systems were progressively stripped from the laid-up ship. Her propulsion plant was never returned to operational service. The ghost ship of Gotenhofen spent the next 2 years rotting under layers of camouflage netting. A simpler repair might have offered Gneisenau a better chance of returning to service, but even that outcome was far from certain. Her future still depended on Hitler's policy, available fuel and crews, escort resources, and the worsening Allied air threat. Gneisenau would never fire her massive new guns at an enemy fleet. But in a strange twist of history, the guns would go on fighting without the ship. By the spring of 1945, the collapsing Third Reich was caught in a desperate, scorched earth retreat. The Soviet Red Army was rapidly advancing across Poland, their artillery thundering just miles from the Gotenhofen naval base. The German military urgently needed to block the harbor entrance to prevent the approaching Soviet forces from utilizing the port facilities. For this grim task, they turned to the rusting, decapitated hulk that had once been the pride of the fleet. Late in March 1945, sources placed the operation on either March 23rd or March 27th. The stripped hulk of Gneisenau was moved into the harbor entrance and scuttled as a block ship. The precise towing arrangements and the placement of the demolition charges are not consistently documented. The irony was brutal. A capital ship engineered to outrun enemy fleets ended her career fixed in the mud by her own navy, obstructing the channel she had once been built to command. The steel that had been meant to dominate the Atlantic had been reduced to a pile of rubble without a purpose. The weapons removed from the ship followed a different fate. Following Hitler's furious decree to dismantle the surface fleet, the German High Command ordered the ship's massive weapons to be repurposed as coastal artillery. Emplacing a naval turret on land is an immense architectural undertaking. A warship's turret is not simply a gun mounted on a deck. It is a multi-story mechanical fortress. To install these weapons on the coastline, engineers had to blast massive craters into the bedrock of occupied Europe. They poured thousands of tons of concrete to artificially replicate the armored cylindrical barbettes, subterranean ammunition hoists, and deep magazine compartments of a battleship hull. The surviving 28-centimeter turrets and guns removed from Gneisenau were dispersed among coastal batteries, including major installations in Norway and the Netherlands. The 38-centimeter weapons intended for the rearmament followed a different path. Components were redirected to coastal projects, particularly in Denmark, but the planned twin-turret system was never completed and deployed in the form imagined for the battleship. The ultimate trade-off of the ambitious reconstruction was finalized. Weapons engineered by naval architects for unmatched global mobility, designed to be stabilized on a rolling ocean, were instead permanently bolted into concrete geography. They were forced to wait for an enemy fleet to come to them. Today, the most complete surviving relic of this doomed engineering saga stands at Ostrot Fort in Norway. Gneisenau's aft 11-inch turret, Turret Caesar, has been preserved and restored as a museum installation, retaining its naval rangefinders, internal loading machinery, and many original fittings. In 1942, Gneisenau had survived the relentless fury of the English Channel, only to be crippled by a single bomb in a supposedly safe harbor. Her commanders launched a radical reconstruction rather than return a compromised ship to war. But by severing her bow to accommodate heavier guns, they tied her to a dockyard until the political winds changed. The ambition to make her perfect was exactly what destroyed her. Now bolted to the earth, Turret Caesar stares out over an ocean the ship herself would never cross again.